Here is an induction question. Ask you to prove this equation by induction. Okay, the given equation is summations on the left-hand side, and this is another expression with the power on the right-hand side. So how to do to prove left equals to right by induction? Okay, okay, look at this. N can be any integer over here. So when we prove left equals to right, it must be for all n's, there is a elements of integer, positive integer in this case. So before we start, we may want to let the statement be Pn for this statement. Let Pn be the statement. Okay, for all n greater or equals to 1. And then when n equals to 1, proof by induction, when n equal 1, the left hand side we have, okay, then n is 1. So from r equal 1 to 1. So three r. So the answer will be 1 times 3 to the power 1 equals to 3. Okay, 1 times 3 to the power 1 equals to 3. Then how about right hand side? Right hand side, if n is 1, so the answer is also 3. So left hand side is equals to 3, right hand side is equals to 3 when n equals to 1. So therefore we can say the statement is true for P1. So we can assume, in this case we assume that it is also true for pk. It means n equals to k, because for all k is elements of integer, positive integer. And then how about if n is equals to k, we assume that both sides are equal. We assume that both sides equal, so therefore because we assume when n equals to k, left is equals to right. N equals to 1, left is equals to right. So when n equal k, left is equals to right. See that we just make an assumption. So k. Just replace the n by k. Okay. So now we want to prove that since we want to prove that left is always equals to right for whatever number of n. So we want to prove, since we found that n equals to 1, left is equals to right, and then we assume that n equals to k, left is also equals to right. So now we must prove that you want to prove if it is true for p k plus 1. Okay, therefore when n is equals to k plus 1, the left hand side will be what? This will be k plus 1, the n, k plus k plus 1 equals to 3 quarter plus 1 quarter 2n becomes k, the n becomes k plus 1 minus 1, 3 the power n plus 1, so the n is a k plus 1 plus 1. Okay, we want to check, is this equal? Is the left equals to the right? So can we check the left hand side? The left of this. So if we expand the summation, this will be 1 bracket 1 the power half, 1 times 3 the power 1, 2 times 3 the power 2, and then all the way to k times 3 the power k plus 1 times 3 the power k plus 1. And we know that the first k term is given here. Is that what the assumption that we made? The first k term is equals to what? 3 quarter plus 1 quarter 2k minus 1, 3 times k plus 1, and then plus k plus 1, 3k plus 1. So we can tidy up this expression. Okay, how to tidy up this expression? Expand it and tidy up. We may want to collect all the like terms. 3 to the k plus 1, 3 to the power k plus 1. Collect all the like terms. And we want this left hand side equals to this right hand side, that the left equals to right. So make sure that we want to get this expression. If we can get this expression here, then left is equals to right. Okay, for n equals to k plus 1. So we want to make sure that when we tidy up this expression is equal to this. So 3 quarter we want to take up 1 quarter. And can take up the 3. Okay, 3 to the power nothing means 3 to the power 1. So 3 to the power 1, 3 to the power k plus 1. You want to combine the 2 3. Can combine these 2 3s. Okay. So 1 quarter. K plus 1 plus 1. Okay, try to make it is so we are nearly there. If you look at the two expression, this is what 2k 2 times bracket k plus 1 minus 1. So how to make this equals to this? Okay, we we make it like 2k plus 1 plus 1 minus 1. Okay, plus 1 minus 1 is 0, so we didn't change the original expression. It's still the same. The reason we are doing this, playing around with the numbers, is to get this expression. So we have 2k plus 2 minus 1. So bring up the light term. So it's equals to the right hand side of this. So we have proved it. So this is the left hand side, and then this is the right hand side for the n equals to k plus 1. Therefore, this statement is true for n equals to 1, and then we assume that it's true for n equals to k, and then we also have proof that it is also true for n equals to k plus 1. Okay, k plus 1, so left equals to right.